Welcome to the C1 presentation for C1 controls about the rules, procedures, and the airspace classes in Denmark. The step from S3 to C1 is small but significant because now you are controlling so many different frequencies, so many different airspaces that you must have an understanding of how it all works and what specifically to know. What we're going to be looking at is the airspace classes, complete overview of everything there is in Denmark. We're going to look at the EKDK sectors and the frequencies, the letters of agreement, and we're going to look at the accepted separation and speed controls procedures. So let's just start with the airspace classes. We'll take it all the way from the beginning. So airspaces, we'll take it off from the beginning. As you know, you control everything, so pause if you need to absorb everything. First of all, you have the control zones. They all go from the ground to 1500 feet and are present in Copenhagen, Roskilde, Billund, Skrydstrup, Karup, Aarhus and Aalborg. That's all pretty simple and you should have known that by now. The next, we got the traffic information zone. They go from ground up to 3,500 feet in Odense, Sønderborg, Vamdrup and Esbjerg. As you can see, they just go a little bit further up than the control zones at this point. Everything outside of that will be the uncontrolled airspace, of course, airspace class Golf. Moving a step up, the next thing you have is, of course, the TMAs. Now, these TMAs generally are present in the same airports as the control zones, with the Aalborg, Aarhus and Karup go to 3,500 feet, same thing as Skrydstrup, while also you have the higher ones, which is the Billund, all the way up to flight level 105. And also you have even the Copenhagen one, which goes even further up, all the way up to flight level 195. So the TMAs are built on top, just like this, as boxes on top of the control zone, on top of the traffic information zones as well. Now TMA does not equal the clearance limit, because as you reach toward the western region of Denmark, you also have more airspace controlled locally, which is the CTAs, which are just going a little bit further up. As you can see down in Skrydstrup and Aarhus, it goes up to flight level 65, whereas in Billund, Karup and Aalborg, the local area of control goes all the way up to flight level 125. This means the ATC can control the airspace all the way up to flight level 125. However, everything outside of it is still airspace class Echo. Next comes the ACC sectors, all the way on the top. Now, they're split as follows, with the different sectors being the lower ones into Copenhagen up to 285 and 245 respectively. And you have the two very big sectors in the east and west, that is the N and S, which is covering much more up. Now, only in the east the sectors are generally split, so that you also have the higher ones on the top of the lower ones. That comes there. If we zoom out on the picture, we can see that where this is normally B and D, there is also the upper airspace in the east, where it separates all the way up from flight number 285 and flight number 245 respectively, all the way up to flight number 660. Let's look at the Rønne airport real quick. Rønne is there at the eastern side of Denmark, completely surrounded by Sweden control. Few interesting things to note here is that the TMA is actually only class Delta up to 4,500 feet. The rest of it is class Echo and is actually been dedicated to Sweden control. This means that when you are controlling Rønne, you are controlling the TMA and control zone simultaneously. You'll be able to see as well that it's actually the same frequency. And you only control this small area here, and you control it from the ground at only up to 4,500 feet. Everything else is Sweden. So concerning all departures, they are given by you as Copenhagen Control, because you control the area around Rønne, but it is given on behalf of Sweden, who are issuing the clearance. So Sweden is telling you what clearance to give, and you will give it to the aircraft, and everything must always be coordinated: runway, routings and altitudes. Normally a standard clearance would be departure runway 29, after departure to Tibro, climb 4000, squawk 0244 for example. And then it needs to be transferred to Sweden immediately after takeoff. It can be direct Tibro, it can be runway heading, it can be whatever Sweden says, and the climb limit is always 4,000 feet. You're only controlling a control zone and a tiny TMA out of order. That's it. Now, this might be a little bit of a mess, so let's dig a little bit further into the sectors and the frequencies. You see the airspace buildup. Now we're going to look into these different EKDK sectors. In reality there are 13, but on VATSIM we're utilizing 6 frequencies. These are Echo Kilo Delta Kilo Bravo, Victor, Delta, Sierra, November, and Charlie. We can split these up into 2 different categories, the primary frequencies and the secondary frequencies. The EKDK Bravo is normally the main EKDK, also known as just EKDK control, and normally controls everything when no one else is online. The EKDK-V is the second one that comes on and splits it up into West Denmark and the upper part, and then the EKDK-B will control the lower airspace around Copenhagen, making for a much smoother entry of traffic into Copenhagen. Further on, the EKDK Delta is basically a split of the Bravo frequencies, which will make the lower eastern Denmark split into 2 different frequencies, one's covering the one from northwest and the other one the one covering from the southwest. These have the ability of taking over from one another in the order. So if all 3 is online and EKDK-B locks off, EKDK-V can take over. On the other hand, we have the secondary frequency EKDK-S, which is the southern Denmark. It goes both lower and upper airspace, all the way from the ground up to flight level 660. Northern one is the North Sea sector, has the same structure, lower and upper. The last one, EKDK Charlie, is the southeast Denmark between Sweden and Maastricht, only on the upper. So that is flight level 285 and above. Now, these are secondary frequency, meaning that they only cover the designated airspaces and does not take over from other sectors if they go offline. So looking at the whole 3D schematic, EKDK Bravo, or just EKDK Control, normally controls everything. Then if we have to do the split, EKDK Bravo will become this tiny little one, controlling the eastern part of Denmark, and more specifically all the arrivals and departures in and out of Copenhagen, with the EKDK Victor then taking the upper airspace above Bravo and also all the western Denmark airspace. This will concentrate Bravo on Copenhagen and Victor on the other ones. Next, at the airspace class Delta, as mentioned, it's basically a split of the Bravo control, making it easier to vector people into Copenhagen, as this one now is 2 different frequencies. That's for the lower frequencies. If we go on the small side note here, normally it's up to flight level 285, but remember there is this kind of small shelf above EKDK control in the north that only goes to flight level 245. This does have some sort of saying in regards to how high you can climb aircraft and how low you will get them. So normally climbing aircraft is to flight level 280 and then handing over to upper airspace, but going to the northwest it's only climbing to flight level 240. As we look to the upper airspace, EKDK Victor is still controlling everything until the secondary frequencies comes and take over, which is the Charlie control that controls the 2 upper sectors of EKDK. It is the EKDK-S that is controlling the southern part and the entire range from the ground all the way up. And lastly, the EKDK North sector there, or North Sea sector, can come in and control everything from the ground up out there in the west. Just to see big from a top-down point of view, you have the lower sectors, EKDK, split up to Victor, split up to the Delta, and then on the lower part, the North Sea sector and the South sector will be present as well. If it's on the upper sector, then again, if nothing else is online, EKDK control, EKDK-V will take over everything that is on the upper airspace. Then it will be split up. We have the North Sea sector again, the Southern sector, and lastly the Charlie sector will take over on the upper airspace part. So, a little bit confusing, but I'm sure you'll get there. Look at the letters of agreement. This we have to start looking at much more intensely. You were introduced to it at your S3 stage, but now it has become more advanced. We have LOA agreements with 4 countries. It's Sweden, Norway, Germany, and Scottish. If we are going to go ahead and take a look at Sweden first, this is definitely the most complicated one. There is different directs you can give compared to from what sectors and to which sectors. Further on to the north, ESMM 5 which is where you can take it from the Victor sector. You can send them to these points. They will be much more detailed in the actual LOA. Same thing for the south. If you come down from the A sector, which is controlled by the C normally, you can go over to these. Now you can't go from the V sector to a point of the 8 or 9 sector. So from the red area you can't go to the blue area. It has to be confined as such. The last one there is the green area, which is into the sector 2 and 3 of Sweden, where you have these points where that can be cleared in from any sectors in Denmark. Also known down in the south, you can clear direct to Rønne and Amager, but still keep in mind it has to go via the sector 2-3 first hand. It's very difficult, but study in the Swedish LOA to get an overview of all these points. Restriction wise, you can descend, or you have to descend, inbounds into Gothenburg to flight number 130, and the points is via Mako and Loppi, where you have to give the arrival into Gothenburg. Next, looking at Norway, you have quite a few different directs you can give as well. That is the Ipton, Valdi, Gunpa, Orvik for all the Atlantic crossings. You can give Rivex, Tukmo and Pipex as well, with a few restrictions, being that the Tukmo is generally for aircraft going to Stavanger and Haugesund, where the Rivex is when you go up to Bergen. Pipex is a very important direct, which is normally given for people going in via Ripam to Oslo Gardermoen. Also, you have the Am7 Artor, which are the points that goes into Kjevik, and the Artor points going into Torp and Rüge. The descent has to be flight level 200 at these points. Now, one thing to be very aware of with inbound to Oslo is if they're filing into Gardermoen at Artor, that is a no-go. Inbounds to Gardermoen must always go via Ripam or Lunep, so you must re-clear them to one of these points that make sense and coordinate with appropriate ATC. This is because the departures out of Gardermoen comes via Artor. Looking lastly at Bremen, there is a lot of directs you can give in Bremen as well. Generally, these are confined from the A and C sector in Denmark down to the Maastricht sectors in Germany. And these are all the VOR points, which is Michaelsdorf, Ilde, Brünkendorf, Leine, Osnabrück, Warberg, Helingen, and of course Rimet. Also, you have quite a few restrictions going into Bremen. Departures out of Billund must be 240 by Tuska, and arrivals into Hamburg must be flight level 200 by Michaelsdorf and flight level 220 by Tuktu. Make sure you know these. From the Bremen point of view, there are going to be some descents into Copenhagen for the arrivals as well, with 340 where they come via Tutlo, and 280 via Geska, 200 via Nikla and Kosep. Again, look into the LOA for a very detailed description of these things. It must be mentioned as well that we do not at this time have any specific directs or procedures with Scottish. Lastly, let's go and look at the accepted separation and speed control. Now, separation wise, there is a few variations. Now, for the two aircraft on the same route, same level, or close to the same level, there must be a minimum distance of 10 miles. This is, though, governed by the fact that the one in the front must be faster than the one in the back. When they're crossing the same level, again, the distance is normally 10 miles. You can actually go down to 5, but for the VATSIM purposes, and because we're dealing with amateur pilots, maintain 10 nautical miles for crossing traffic as well. How you separate them is also a little bit different, because at high levels you must give them Mach restrictions. Now, heavies normally cruise at Mach 80 to 88, normally 84, where mediums normally cruise at Mach 70 to 80, or normally 78. To separate two en route traffic from each other, normally you ask the preceding, the first one, what Mach number he's flying, and then you make sure the one behind is being matched. So when do you actually give Mach restrictions? So when do you actually give Mach restrictions and when do you give speed restrictions? For that, we gotta talk about a crossover. A crossover is when you are converting Mach to airspeed. So that is when the airspeed limitation, for example 280 knots or greater, must become a Mach limitation. Normally it happens between flight level 260 and flight level 290, depending on the aircraft speed, which as a rule of thumb would mean don't give a Mach restriction below flight level 260, don't give an airspeed restriction above flight level 290. If you are descending and you want them to keep speed at a high altitude, the phraseology to keep that is to, on conversion, speed, for example, 300 knots or greater. This means as when they get into the conversion zone where the Mach number goes to speed, then they will maintain 300 knots. When it will change is depending on the Mach number. However, Mach number at high altitudes will be more or less the same from all aircraft. Difference from Mach 7.8 to 8.4 is not really that much. What is going to happen for an airplane wise is normally they will descend, for example, at Mach 7.8 and on conversion speed 320. They will descend from flight level 320 with their Mach 7.8. At some point, they will go lower and lower and their speed will increase to maintain that Mach number. At some point, which will be at 320, then they will hit this critical conversion zone where the Mach will become an airspeed. From there on, it will descend with the airspeed and the Mach number will continue to get lower and lower as it descends through the layers. So that is the end of the presentation. I hope you got a little bit smarter and go enjoy your C1 training, and that's it.